The clinical need that we are addressing is the harmful effects of UVB exposure. Increased UVB exposure puts you at risk for various cancers like melanoma and non-melanoma cancers because of the damage it causes to DNA. Additionally, UV exposure can lead to very painful sunburn. An increased history of sunburn also increases the risk of cancer. We sought to create a useful wearable technology that can alert the user when they are getting too much UVB exposure. We wanted the device to allow the user to see how close they are to getting burnt and seek protection by going to a low UV environment or putting sunscreen on before this happens. The device also warns the user of high heat when they are at risk of dehydration. The biggest advantage of our device is the use of a color pal. This allows us to monitor the pigment of skin, which has an impact on how fast you burn. For example, as you get tan, you burn at a different rate. Incorporating this information provides personalization and accuracy. The various inputs in the device include a real-time clock module, which runs on a battery, a variable resistance thermistor for temperature reading, a push button for a variety of inputs depending on time, a color pal where red values are used for skin color, and an ML8511 UV monitor for monitoring 280 to 390 nanometers of light most effectively. This is the UVB range. As an output, we use a micro LCD display. Using data from medical literature, we were able to develop equations with a powered trend line for correlating UVB intensity with time till burn. Through the literature, we also found how skin color speeds or slows burn. From this, we divided skin colors into 4 categories and had 4 equations for burn rate. We developed a method of finding a percent burn according to these equations. When the percent burn is at 100, the user is alerted that it is time to put on sunscreen.
As you can see on our LCD screen, our device has an internal clock that allows you to see the time of day at any point in time. It also displays the ambient temperature to let the user know how hot it is outside. We also display the UV readings from 1 to 12 so that the user is aware of what the current UV is. Using the algorithm we created, our UV monitor determines when you reach 100% burn rate, depending on the skin color, how much time you've been outside, and the current UV reading. Our device continues to work as a watch until you receive too much UV radiation and reach 100% burn rate. Once this occurs, our LCD displays an alert that reminds the user to reapply sunscreen. The user then presses the push button to indicate that they have reapplied. The UV monitor restarts and begins recalculating the user's burn rate once again, taking into account the time that was previously spent outside. Here you can see our Color Pal sensor working and reading someone's skin color. The sensor then measures the user's skin color in order to determine what their exact burn threshold is.
If the temperature becomes too high, it warns you that you're at risk for dehydration and should drink more water.
At any point in time, the user can press the push button in order to see what their current percent burn rate is. Finally, here are the results that show up on the serial monitor, just to prove that our device is working well.
Here's a mock-up of what our product would actually look like. It would be much smaller and would be modeled after a smartwatch. The color sensor would be underneath to continuously take color inputs from the wrist.
Our product has some advantages compared to the other products already out there. For starters, our UV monitor is more accurate because it takes in the differences of people's skin color and then determines how long it will take them to burn. Our device is also in a watch format, so it has built-in timing and is worn on a part of the body that is often exposed to the sun. However, some limitations of our device are that the UV sensor needs to be positioned very accurately towards the sun. Also, more data needs to be obtained in order to have exact equations between skin color and burn rate. Additionally, our working prototype is not yet small enough as would be necessary for a watch.